What is a message queue, and why is it important in DevOps?
A message queue is a middleware component that enables asynchronous communication between services by storing messages until the consumer is ready to process them. It decouples producers from consumers, allowing services to operate independently and handle varying loads. Message queues are critical in DevOps for building resilient, scalable microservices architectures.
What is the difference between a message queue and event streaming?
A message queue delivers messages to a single consumer and typically removes the message after processing. Event streaming platforms like Kafka persist events in an ordered log that can be consumed by multiple consumers independently and replayed from any point. Message queues are best for task distribution, while event streaming is ideal for event-driven architectures and data pipelines.
What is Apache Kafka?
Apache Kafka is a distributed event streaming platform designed for high-throughput, fault-tolerant, and durable message processing. It stores streams of records in topics partitioned across multiple brokers, supporting both real-time stream processing and batch data integration. Kafka is used for event sourcing, log aggregation, metrics collection, and building real-time data pipelines.
What is a Kafka topic?
A Kafka topic is a named feed or category to which records are published. Topics are divided into partitions that are distributed across Kafka brokers for scalability and parallelism. Each partition maintains an ordered, immutable sequence of records with offsets. Topics can be configured with retention policies based on time or size.
What are Kafka partitions, and why are they important?
Kafka partitions are the unit of parallelism within a topic, each being an ordered, immutable log of records. Partitions allow a topic to be distributed across multiple brokers for horizontal scalability. The number of partitions determines the maximum number of consumers in a consumer group. Records with the same key are always sent to the same partition, ensuring ordering for related events.
What is a Kafka consumer group?
A Kafka consumer group is a set of consumers that cooperatively consume records from a topic, with each partition assigned to exactly one consumer in the group. This provides parallel processing while ensuring each record is processed once per group. Multiple consumer groups can independently read the same topic, enabling different applications to process the same data stream.
What is the role of a Kafka broker?
A Kafka broker is a server that stores topic partitions and serves client requests. Each broker handles reads and writes for the partitions it owns. A Kafka cluster consists of multiple brokers for fault tolerance, with one broker acting as the controller that manages partition leadership. Brokers replicate data across the cluster for durability.
What is Kafka replication?
Kafka replicates each partition across multiple brokers to provide fault tolerance. Each partition has one leader that handles all reads and writes, and one or more followers that replicate the data. The replication factor determines how many copies exist. If the leader fails, one of the in-sync replicas is elected as the new leader automatically.
What is the difference between at most once, at least once, and exactly once delivery?
At most once delivery means messages may be lost, but are never duplicated, which is the fastest option. At least once delivery ensures messages are never lost, but may be delivered multiple times, requiring idempotent consumers. Exactly once delivery guarantees each message is processed precisely once, which is the strongest guarantee but has the highest performance overhead.
How does Kafka achieve exactly once semantics?
Kafka achieves exactly once semantics through idempotent producers that prevent duplicate writes, and transactions that enable atomic writes across multiple partitions. The transactional IP, I, allows producing and consuming offsets to be committed atomically. This ensures that even if a producer retries, records are not duplicated, and consumer processing is consistent.
What is a Kafka offset?
An offset is a sequential number assigned to each record within a partition, serving as its unique identifier. Consumers track their position in each partition by committing offsets. When a consumer restarts, it resumes from the last committed offset. Offsets can be committed automatically or manually, with manual commits providing more control over exactly once processing.
What is Zookeeper, and what is its role in Kafka?
Zookeeper is a distributed coordination service that Kafka traditionally used for broker registration, leader election, topic configuration, and consumer group coordination. Starting with Kafka 3.x, K-Raft mode replaces Zookeeper with an internal Raft-based consensus protocol, simplifying Kafka's architecture by eliminating the external dependency.
What is K-Raft mode in Kafka?
K-Raft is Kafka's built-in consensus protocol based on Raft that replaces the dependency on Zookeeper. In K-Raft mode, metadata management is handled by a quorum of controller nodes within the Kafka cluster itself. This simplifies deployment, reduces operational complexity, improves scalability, and eliminates the need to manage a separate Zookeeper ensemble.
What is Kafka Connect?
Kafka Connect is a framework for streaming data between Kafka and external systems like databases, key-value stores, search indexes, and file systems. It uses connectors, which are reusable plugins, with source connectors pulling data into Kafka and sync connectors pushing data out. Connect handles offset tracking, scaling, and fault tolerance automatically.
What is Kafka Streams?
Kafka Streams is a client library for building real-time stream processing applications that read from and write to Kafka topics. It supports operations like filtering, mapping, joining, windowing, and aggregation. Unlike standalone processing frameworks, Kafka Streams runs as part of your application without requiring a separate cluster, making it lightweight and easy to deploy.
What is Schema Registry in Kafka?
Schema Registry is a service that stores and manages schemas for Kafka record keys and values, typically using Avro, Protobuf, or JSON schema formats. Producers register schemas before sending data, and consumers retrieve schemas to deserialize records. It enforces schema compatibility rules to prevent breaking changes, ensuring reliable data exchange between producers and consumers.
What is RabbitMQ?
RabbitMQ is an open-source message broker that implements the MQP protocol and supports additional protocols like MQTT and STOMP. It provides features including message routing through exchanges, message acknowledgement, delivery guarantees, clustering, and plugin extensibility. RabbitMQ excels at complex routing patterns and is widely used for task queues and RPC-style communication.
What are exchanges in RabbitMQ?
Exchanges are routing components in RabbitMQ that receive messages from producers and route them to queues based on rules called bindings. There are 4 exchange types: direct, which routes by exact routing key match; fan-out, which broadcasts to all bound queues; topic, which routes by pattern matching on routing keys; and headers, which routes based on message header attributes.
What is a direct exchange in RabbitMQ?
A direct exchange routes messages to queues whose binding key exactly matches the routing key of the message. This provides point-to-point messaging, where each message goes to a specific queue. It is the simplest routing strategy and is commonly used for task distribution, where messages need to reach a specific consumer or queue.
What is a fan-out exchange in RabbitMQ?
A fan-out exchange broadcasts every message to all queues bound to it, ignoring routing keys. This implements the publish-subscribe pattern, where multiple consumers each receive a copy of every message. It is useful for broadcasting events like notifications, log distribution, or updating multiple caches simultaneously.
What is a topic exchange in RabbitMQ?
A topic exchange routes messages based on pattern matching between the routing key and the binding pattern. Routing keys use dot-separated words, and patterns can use asterisk to match one word or hash to match 0 or more words. This enables flexible routing, where consumers can subscribe to subsets of messages based on hierarchical categories.
What is message acknowledgement in RabbitMQ?
Message acknowledgement is a mechanism where consumers confirm to RabbitMQ that a message has been successfully processed. If a consumer crashes before acknowledging, RabbitMQ redelivers the message to another consumer. Acknowledgements can be automatic or manual, with manual acknowledgements providing stronger delivery guarantees. Negative acknowledgements can reject and optionally requeue messages.
What is a dead letter queue?
A dead letter queue is a special queue that stores messages that cannot be processed successfully after a defined number of attempts. Messages are routed to the dead letter queue when they are rejected, expire, or exceed the maximum delivery count. This prevents problematic messages from blocking the main queue and allows operators to investigate and reprocess failed messages.
How does RabbitMQ clustering work?
RabbitMQ clustering connects multiple nodes that share users, virtual hosts, queues, exchanges, and bindings. By default, queues reside on a single node with metadata replicated across all nodes. Quorum queues provide replicated queues using the Raft protocol for data safety. Clusters improve availability and throughput, and nodes can be added or removed without downtime.
What are quorum queues in RabbitMQ?
Quorum queues are replicated queues in RabbitMQ that use the Raft consensus algorithm to maintain data safety across multiple nodes. They replace the older mirrored queues with better performance and predictable behavior. Quorum queues ensure that messages are not lost if a node fails and provide automatic leader election for continued availability.
What is NITS?
NITS is a lightweight, high-performance messaging system designed for cloud-native applications. It supports publish-subscribe, request-reply, and queue group patterns with minimal operational overhead. NITS is written in Go and focuses on simplicity and speed. Jetstream extends NITS with persistence, exactly once delivery, and stream processing capabilities.
What is NITS Jetstream?
Jetstream is the built-in persistence layer for NITS that provides durable message storage, replay capabilities, consumer acknowledgements, and exactly once delivery semantics. It supports stream-based messaging with configurable retention policies, consumer groups, and key value and object storage. Jetstream makes NITS suitable for use cases that require durability beyond simple pub/sub.
What is the publish-subscribe pattern?
The publish-subscribe pattern decouples message producers from consumers by introducing a topic or channel as an intermediary. Publishers send messages to a topic without knowledge of who will receive them, and subscribers receive messages from topics they have subscribed to. This enables one-to-many communication and is fundamental to event-driven architectures.
What is the competing consumers pattern?
The competing consumers pattern distributes messages from a single queue across multiple consumer instances, with each message processed by exactly one consumer. This provides horizontal scalability for workload processing. In RabbitMQ, this is the default queue behavior. In Kafka, it is achieved through consumer groups, and in NITS through queue groups.
What is event-driven architecture?
Event-driven architecture is a software design pattern where system components communicate through events rather than direct calls. When something significant happens, a service publishes an event that other interested services can react to. This reduces coupling between services, improves scalability, and enables reactive systems that respond to changes in real time.
What is event sourcing?
Event sourcing is a pattern where the state of a system is determined by a sequence of events rather than the current state alone. Every state change is captured as an immutable event in an append-only log. The current state is derived by replaying events from the beginning. Kafka's durable, ordered log makes it a natural fit for event sourcing implementations.
What is CQRS, and how does it relate to message queues?
CQRS, or Command Query Responsibility Segregation, separates read and write operations into different models. Write operations produce events that are published to a message queue or event stream, and read models consume these events to build optimized query views. This pattern enables independent scaling of reads and writes and works naturally with event-driven messaging systems.
What is message serialization, and why does it matter?
Message serialization is the process of converting structured data into a byte format for transmission through a message queue. Common formats include JSON for readability, Avro and Protobuf for compact binary encoding with schema support, and MessagePack for fast binary encoding. The choice affects performance, interoperability, and the ability to evolve message formats over time.
What is backpressure in messaging systems?
Backpressure is a mechanism that prevents fast producers from overwhelming slow consumers by slowing down the rate of message production. Different systems handle backpressure differently. Kafka uses consumer-side pull semantics so consumers control their pace. RabbitMQ can apply flow control when queues reach memory limits. Proper backpressure handling is crucial for system stability.
How do you monitor a Kafka cluster?
Kafka monitoring involves tracking broker metrics like request rates, partition counts, and replication lag, as well as consumer metrics like consumer lag, commit rates, and processing throughput. Tools like Prometheus with JMX Exporter collect Kafka metrics, and Grafana visualizes them. Burrow or Kafka Lag Exporter specifically monitor consumer group lag. Alerting on consumer lag and under-replicated partitions is essential.
What is consumer lag in Kafka?
Consumer lag is the difference between the latest offset in a partition and the consumer group's committed offset. It indicates how far behind a consumer is in processing messages. High consumer lag means the consumer cannot keep up with the producer rate and may need scaling. Monitoring lag is critical because excessive lag can lead to data staleness and potential data loss when retention limits are reached.
What is message ordering, and how do different systems guarantee it?
Message ordering ensures messages are delivered in the same sequence they were produced. Kafka guarantees ordering within a partition, but not across partitions. RabbitMQ provides ordering within a single queue from a single producer. NITS provides ordering per subject. When strict global ordering is required, messages must be routed to a single partition or queue, which limits parallelism.
What is a message broker vs a message queue?
A message broker is a broader category that includes routing, transformation, and protocol mediation capabilities, with RabbitMQ being a prime example. A message queue is specifically the component that stores messages between producers and consumers. Event streaming platforms like Kafka go beyond both by providing a durable, replayable event log. The terms are often used interchangeably in practice.
What is idempotency in message processing?
Idempotency means that processing the same message multiple times produces the same result as processing it once. This is critical in at least once delivery systems where messages may be redelivered. Idempotent processing is typically achieved using unique message identifiers and deduplication logic, or by designing operations that are naturally idempotent, like setting a value rather than incrementing it.
How do you handle poison messages?
Poison messages are messages that consistently fail processing, potentially blocking the queue. Handling strategies include configuring a maximum retry count, after which the message moves to a dead letter queue, implementing exponential backoff between retries, logging the message details for investigation, and alerting operators. This prevents a single bad message from halting the entire processing pipeline.
What is Amazon SQS?
Amazon's Simple Queue service is a fully managed message queue service from AWS. It offers standard queues with at least once delivery and best effort ordering, and FIFO queues with exactly once processing and strict ordering. SQS eliminates the operational burden of managing queue infrastructure and integrates with other AWS services like Lambda for serverless processing.
What is Amazon SNS?
Amazon's Simple Notification Service is a managed pub/sub messaging service from AWS. It supports fan-out to multiple subscribers including SQS queues, Lambda functions, HTTP endpoints, and email. SNS provides message filtering so subscribers receive only relevant messages. It is commonly paired with SQS in a fan-out pattern for reliable, decoupled event distribution.
What is Amazon Kinesis, and how does it compare to Kafka?
Amazon Kinesis is a managed event streaming service from AWS that processes real-time data at scale. Like Kafka, it uses shards similar to partitions for parallel processing. Kinesis integrates deeply with AWS services, but has lower throughput limits per shard compared to Kafka partitions. Kafka provides more flexibility and features, while Kinesis offers simpler operations as a managed service.
How do you choose between Kafka and RabbitMQ?
Choose Kafka when you need high-throughput event streaming, event replay, multiple consumers for the same data, or long-term message retention. Choose RabbitMQ when you need complex routing patterns, priority queues, flexible acknowledgement, or traditional task queue behavior. Kafka excels at data pipelines and event-driven architectures, while RabbitMQ excels at application-level messaging and task distribution.
What is Message TTL?
Message TTL, or time to live, defines how long a message remains in a queue before being discarded or moved to a dead letter queue. In RabbitMQ, TTL can be set per message or per queue. In Kafka, retention is configured at the topic level by time or size. TTL prevents queues from growing indefinitely and ensures consumers process only relevant, timely data.
What is a saga pattern in distributed messaging?
The saga pattern manages distributed transactions across multiple services using a sequence of local transactions coordinated through messages. Each service performs its transaction and publishes an event. If a step fails, compensating transactions are triggered to undo previous steps. Sagas can be choreographed through events or orchestrated by a central coordinator, and message queues are the typical communication mechanism.
How do you scale Kafka consumers?
Kafka consumers are scaled by adding more instances to a consumer group, up to the number of partitions in the topic. Each partition is assigned to exactly one consumer in the group, so the maximum parallelism equals the partition count. If you need more parallelism, you must increase the number of partitions. Consumer groups automatically rebalance partition assignments when members join or leave.
What is Kafka Mirror Maker?
Kafka Mirror Maker is a tool for replicating data between Kafka clusters, commonly used for disaster recovery, geographic distribution, and data aggregation. Mirror Maker 2, based on Kafka Connect, provides offset translation, automatic topic creation, and checkpoint synchronization. It enables cross-data center replication while maintaining the original topic structure and consumer offsets.
What are virtual hosts in RabbitMQ?
Virtual hosts in RabbitMQ provide logical separation within a single broker, similar to namespaces. Each virtual host has its own set of exchanges, queues, bindings, and permissions. They allow multiple applications or teams to share a RabbitMQ cluster with complete isolation. Users are granted access to specific virtual hosts with configurable permissions for different operations.
What is the outbox pattern in event-driven systems?
The outbox pattern solves the dual write problem where a service needs to update its database and publish an event atomically. Instead of publishing directly, the service writes the event to an outbox table in the same database transaction. A separate process reads the outbox table and publishes events to the message broker. This ensures consistency between the database state and published events.